So if you have those even y exponents, as soon as you replace y with negative y, it's going to be even again. Okay, so let's say if you have x equals y to the fourth plus 2y squared. If you want, you can make it f of y and then f of negative y, but you don't have to go through all that. So we have a function of y equals y to the fourth plus 2y squared. Like I said, strictly optional if you want to write it that way. So if we replace y with negative y, that means you have x is equal to negative y to the fourth plus 2 times negative y squared. You know, negative y to the fourth is just y to the fourth because those negatives cancel each other out. So you have y to the fourth plus 2. Negative y times negative y is just positive y squared, which is equal to your original expression. Okay, so it is symmetric across the x-axis. Okay, now it doesn't make this one odd, it doesn't make it even. This would fall under one of those categories as neither. So you have some where they'll have multiple choice questions. They'll say, is this function odd, even, or neither? This would fall under the neither category. Okay, so we know this is neither odd nor even. Neither odd nor even. All right, so any questions on this one? All right. Leave that up for a few seconds and show you a few graphs that you're going to see on your homework. All right, looks like everyone's done. Oh, I didn't know. I thought everybody was done. All right, leave it up for a few more seconds. All done? All right. Anybody else still writing? All right. Okay. You want to know if this is odd, even, or neither? Odd. Yep, this is odd. You can tell it's odd just by if you have a graph and it reflects across the y-axis, and then if you flip it again across the x-axis, that's how you can look and tell it's odd. So it's kind of a, we flip it here, then we flip it over again that way. Okay, so this is odd. Okay, so what about this one?
No, none of them.
It wouldn't be odd because remember it has to go through the origin. Yep, so one like this would fall under the neither category because it's not symmetric across the y-axis. Then if you flipped it across the y-axis, then again over the x-axis, because it's not going through the origin, that's why it's called symmetric about the origin, because it has to actually go through 0, 0. Yep, so this one would be neither. All right, does that make sense? All right. Okay, so this one, how do you, yeah, right across the y-axis. If it looks like a mirror image across the y-axis, it's even. So symmetric across the y-axis. All right. What about this one? Yep, it would be neither. Yep, because it's not even, because it doesn't go across the y-axis. It's not odd, because you could have, yep, it's not going through the origin. Plus, if you have, was this 6, negative 2.5, something like that, you'd have to have a 6 and positive 2.5. Yep, so it would have to go that way. Does that make sense? Yeah. So this would be neither. All right. Any questions on that one? All right. What about that one? Even. Yep, even. Looks like a mirror image right across the y-axis. So this one is even. So symmetric across the y-axis.
Is going to be in the homework like this?
Yep, some of them are going to be like that. Some of them are actually going to give you equations that you have to test. So this is how you're going to see most of the graph problems, at least. All right, so if we have this one. Yep, this one's odd. You can tell because if you flip, let's say this section here, if you flip it across the y-axis and then you flip it again across the x-axis, that's when you end up right there. So if you kind of imagine it that way, even kind of tricky ones like this, you can kind of visualize it a little bit. Does that make sense? All right. Okay, so last but not least, we're going to go over one-to-one functions, which shouldn't take too long. Okay. So we know that a function is when every x value has exactly one y value. That's the actual definition of a function. A function is described when every x value, or in some cases called the input, has exactly one y value, which they sometimes call the output. Okay, so let's say, for example, if you want to determine if the following are functions. Okay, so let's say for A, if you have the point 1, 3, 2, 5, breaking these again. You have 7, 5, you have 3, 4, or the point 4, 8. And let's say for B, if you have the point 2, 7, 3, 4, say you have the point 1, 8, 2, 5, and 4, 1. Okay. So we can see for A that it is a function, because 1 only has one y value. You don't see 1 equal anything else. 2 only has one y value. 7 only has one y value. 3 only has one y value. 4 only has one y value. So it is a function since every x has one y. Okay. Now for b, if you notice, you have 2 equals 7 and 2, well, not 2 equals 7, but 2 and 7 and 2 and 5. So that means x equals 2 has y equals 7 and x equals 2 has y equals 5. So that one's not a function since you have to have exactly 1. Not a function since x equals 2 has both y equals 7 and y equals 5. Oops, straighten that up a little bit. Okay, or if we decide to draw this, so you have 1, 2, 3, 4, A, B, C, and D. Okay, you can tell that one's not a function because your input, yep, has more than one output. Not a function since the input 3 has more than one output. So you may see it any number of ways. Okay. Now a function is a one-to-one function if each x has one y and each y has one x. With just a regular function, you can have an x with, you have to have an x with one y, but you can have y with multiple x values. But with one-to-one, they literally have to be one-to-one. All right, leave that up for a few more seconds. Still see someone writing. All right. Okay. So a function is one-to-one. Straighten that up a little bit. If each x value or your input, I swear I'm going through the, has, well, we can say corresponds to, has only one y value or output, and every y value has only one x value. Okay, so let's say, for example, determine if the function, or each function, is 1-to-1. So determine if each function is 1-to-1. Alright, so let's say for problem A, you have the point 0.62, 0.54, point -10, and the point 0.73. And for problem B, you have the point, draw that a little bit better. So you have the point 0.39, you have -4.2, you have -3.9, and you have 0.0. And let's say for C, we'll throw a graph in there. Okay, so we have 18 to 24. You have 25 to 34. You have 35 to 44. 45 to 54. 55 to 64. And over 60. And this graph represents average text per day. Okay, so you have 50, 20, 10, 6, and 2. And let's say we go there, kind of. Mix that one up a little bit. Okay, so what about A? Yep, this one is actually 1-to-1 because 6 only has one y value. You don't see 6 with a different y value. Same with 5, same with -1, same with 7. Now your y equals 2 only has one y value. Same with 1 x value. Same with 0, same with 3. Okay, so this one, yes, it is 1-to-1. What about B?
It's functional. No, it's not.
It's a function, that's true.
It is?
Yeah, but it's just not 1-to-1.
Yeah, because we have
Yep.
2 0.
Because every x has one y. So 3, you don't see 3 equaling anything else. The only difference is here, y equals 9 has 2 different x values.
-3.
Yep, 3 and -3. So it is a function, just not 1-to-1. That's because you have that one and that one. Okay, so y equals 9 has x equals 3 and x equals -3.
This is